Hello, welcome to my YouTube channel. In this video we're going to look into arrangements. So arrangements mean permutation and arrangements. Okay, let's have a look into warm-up activity first of all. So how many different 4-digit numbers can you make using the digits 1, 2, 3 and 4 without repetition? Try doing this one. What do you think? How many can you? Please write down. Okay, so here are the number of choices. Let's say 1, 2, 3, 4, and you can keep 1, 2 in the beginning, and you can just swap 3 and 4. Then 1, 3, 2, 4, 1, 3, 4, 2, 1, 4, 2, 3, and so on. Similarly, these are all with the 1. So the first row, first column over here, you can see like the 1 is at the first place, and we just swap the numbers 2, 3, and 4. Then in the second column over here you can see like 2 is at the first place, and we just swap the other three numbers like 1, 3 and 4, so we get this many patterns or different 4-digit numbers. Then keeping 3 as a fixed point, and then we move other three numbers. Similarly, this time we fixed 4 over here, and we just replace 1, 2, 3 and 1, 3, 2 to 1, 3. So similarly here, if we have 4 letters A, B and C, D, so if we want to arrange these letters, how many ways could I do it? So try to arrange these. Okay, so here A, B, C, D, then B, C or D. So here you can say there are 12 possibilities for the first two letters. So for the first two letters there are 12 possibilities, so it would be A, B, B, A, C, A, D, A, A, C, B, C, or so. Similarly, for each of the above there are two possibilities for the final two letters. So how many is this altogether? So since we know for the first letter there are 4 possibilities, because whether A can come at the first place, or B can come at the first place, or C can come at the first place, or D can come at the first place. Yeah, so being the first letter there are 4 possibilities over here. So once one of the latter we have chosen, then for the second one there are 3 possibilities, and the third one there are 2 possibilities, and the fourth one there are 1 possibility. So in total, how many? It will be 24 ways, so we can arrange this. So these are the arrangements. So we found here 24 arrangements. Now here, so as you can see, as I explained in the previous slide, so 4 options for the first letter, 3 options for the second one, 2 options for the third one, and 1 option for the fourth letter, because we are not repeating. Okay, so then if we have 5 letters A, B, C, D and E, so first 5 alphabets, if I want to arrange these letters, how many ways could I do? So the rule we have just discussed on the previous slide, so can you try doing that one? So how many ways we can get it? Okay, since you know for the first letter, so it has a 5 options, and for the second letter it has a 4 options, third letter 3 options, and so on. So if you multiply them, so we will get the total possibilities are 120. Okay, so this brings us to know about factorial. As many of you are familiar with factorial from AS, so another way to say 5 times 4 times 3 times 2 times 1 is 5 factorial. So this is a 5 factorial. So in this 5 factorial, so if we expand, basically 5 factorial is equal to 5 times 4 times 3 times 2 times 1. So then what is the value of 6 factorial? So simply you will expand this, so 6 times 3 times 6 times 5 times 4 times 3 times 2 times 1. So basically the general formula for the factorial is n factorial, so it will once you expand it, so it will be n times n minus 1 times n minus 2 times n minus 3 and so on till 3, 2 and 1. Okay, if we have alphabets A, A, B and C, so we have actually 4 places. If I want to arrange these letters, how many ways could I do? So here we need to think of A, A, B, C as A1, A2, B and C. Since you might get confused because A is twice over here, but we are thinking this as a different letter over here. So we have 4 letters. So the first position A1, A2, C, D, then A2, C or D, A1, C or D, then A1, A2 or D, then A1, A2 or C. So again here we can see there are 12 possibilities for the first 2 letters. And then if we consider the arrangements of A1, A2, B, C, we may decide that there are 24 ways of arranging them. So in this way we must remember, however, that A1 and A2 are the same. If we list the arrangements, we may notice that the pairs of the same arrangements are formed because A is gonna repeat it over here. So it will be A1, A2, CD, A2, A1, CD, A2, CD, A1, and A1, CD, A2. So although there are 24 arrangements, half of them will be the same. So this means that there are actually only 12. So if we consider A first letter A1 and second letter A2, but since like this is A, so at the end it will be half of the possibilities will be left over, because we will see if you arrange them, so in total you will find like 24 ways, but since A and A is same, so that's why we are gonna get 12. Okay, so that time if there is a number of ways of arranging A1, A2, C and D, which is 4 factorial, and the number of ways of arranging A1, A2, because it's the same, so 4 factorial over 2 factorial, so this will give us 12 factorial. As you remember, 4 factorial is being expanded like 4 times 3 times 2 times 1, and 2 factorial will be 2 times 1, so 2 and 1 is going to cancel out from the top and the bottom, so 4 times 3 will give us 12 arrangements. Okay, so here another example, AAABBBB. How many ways are there to arrange A1, A2, A3, B, C, D? How many ways are there to arrange A1, A2, A3? So these are different questions. Could you please try doing this one? So, sorry. Here, keeping this in mind, n factorial over r factorial. So using this. So if you can see here, how many ways are there to arrange these numbers? So first of all, look into this 1, 2, 3, 4, 5, and 6. It's 6 factorial over, since a is being replaced 3 times, so 6 factorial over 3 factorial. Then how many ways are there to arrange a1, a2, a3? So basically it's 3 factorial over 3 factorial. And then how many ways are there to arrange A, A, B, C, D? Okay, write down a rule for the number of arrangements, a set of n objects where r of them are identical. So using this, as you saw over here in this one we saw, So the identical letter, how many number of identical letters are here, or whatever the event is going to happen. So we need to bring this down over here. So n factorial is the total possibilities over r factorial. Okay, then in this there is a special case. In order for us to be able to use this to expand expression, we need to consider a special case. So we need to consider a set of n objects of which r are of one kind and the rest n minus r of another one. For example, here we have a, so 5 times a and 3 times b. So arrangements with objects of only two types, because since it's a and b, so if they were all different, there would be 8 factorial ways of arranging them, because there are 8 letters in total. As there are 5 identical a's, we need to divide by 5 factorial. However, there are 3 identical b's, so we need to divide by 3 factorial. So that's mean in total it's 8 factorial definitely, because there are 8 letters, but we need to divide this by 5 factorial times by 3 factorial. So we will simplify this, so we will get the number of choices, which are 56. Okay, arrangements with objects of only two types. So here, as this, we just saw the example. So then we can generalize this rule. So the number of ways of arranging n objects of which r are of one type and n minus r of another type is denoted by ncr. So this gonna be, we can find its value by ncr, or we can write this n factorial over r factorial times n minus r factorial. And here we can see this is 56 possible. Okay, so let's have a look into example. So we have 3 identical A and 6 B's. How many ways are there of arranging them? So since there are 9 letters and R is equal to 3, because 3 are identical, so it will be n CR. So n factorial over R factorial times n minus R factorial. So basically this will be written as 9C3, because these are two identical types of letters. So 9 factorial over 3 factorial and 9 minus 3 factorial. So we simplify this, so we will get 84 number of ways arranging them. Then we can use calculator for this. So if we use a calculator, okay, so in this one, as you saw, like there is an example. So we have two identical letters A and B. So how many ways are there for arranging these? So r is equal to 9, r is equal to 3. So you can simply put in your calculator. So type this 9 followed by ncr followed by 3 and press equal. So it will give you your answer at the end. Okay, so hope this concept is clear, and thanks for watching.